All right, let's look at the homework 2.6, problem number 5. We're going to use the implicit differentiation to find an equation of the tangent line to this curve right here at pi over 2 comma pi over 4. All right, so let's do that. All right, so we're going to go ahead and take the derivative. So take the derivative with respect to x of y times sine of 16x, which is equal to derivative with respect to x of x times cosine of 2y. Right? So there are two things multiplied together, y and the sine of 16x. So we're going to have to use the product rule. Right? So derivative of y would be dy over dx multiplied by the second guy. So you have a sine of 16x plus y, first guy, times derivative of sine of 16x. So which is going to be, derivative of sine is cosine of 16x, but you need to multiply by a derivative inside, which is 16. Right? So we have that. And the right hand side is very similar because you have two things multiplied together. Right? So we're going to take the derivative of x is 1 times the second, so cosine of 2y, plus, right, x times derivative of cosine of 2y would be negative sine of 2y times, then derivative of 2y would be 2 and dy over dx. All right, so we have that. Then we just have to collect all the terms with dy over dx in it. So I'm gonna collect this guy, which is on the left, and we have this guy, which is on the right. All right, so I'm gonna combine those guys together. All right, so both of them have dy over dx, so I'll just pull that out first. All right, so from here you have sine of 16x. Right? From here, so it's going to be negative, so if you put it on the other side, it becomes positive. So you have a 2x sine of 2y. So plus 2x sine of 2y. Right? Then everything else is on the other side. So we have a cosine of 2y, which is already on the right hand side. And I'm going to put this guy on the other side, which becomes changes sign, so negative 16y cosine of 16x. Right? So then we can divide both sides through by sine of 16x plus 2x sine of 2y. We get, we can isolate dy over dx, which is equal to, all right, so right hand side is cosine of 2y minus 16y cosine of 16x all over sine of 16x plus 2x sine of 2y. Right? So it's a little complicated, but that's the derivative. Right? Then what you need to do is we need to plug in pi over 2 for x and pi over 4 for y. So let's do that. So the slope m is going to be dy over dx evaluated at pi over 2 comma pi over 4. All right, so let's do that. All right, so cosine of 2y, so pi over 4 is plugged in, so cosine of pi over 2. Cosine of pi over 2 is actually 0, right? Then you have a negative, right? So you're going to have negative 16 times pi, pi over 4, so it's going to be 4 pi, right? Then you have cosine of, let's see, 16 times pi over 4 would be 4 pi. Cosine of 4 pi is going to be 1, so times 1, right? Then we look at the sine of, oh, actually, sorry, I made a mistake. It's a cosine of 16 times pi over 2, so it's a cosine of 8 pi, which is going to give you 1 anyway, so its answer was still the same. All right, then you have sine of 16x, so this is sine of 8 pi, so that's going to be 0, right? Then you have 2x, so 2 times pi over 2 would be just pi. All right, then you have a sine of 2y, so sine of pi over 4 times 2, so pi over 2. Sine of a pi over 2 would be 1, so it's going to be 1. So you can see that, let's see, this is pi and the pi cancel out, so you're just going to get negative 4. All right, so negative 4 is the slope, so therefore the equation is going to be y minus y1, so it's a pi over 4, which is equal to, slope is negative 4, x minus x1 is pi over 2. All right, so let's type it in. All right, so the slope was negative 4. All right, quantity x minus pi. Let's see, we have to find the Greek letter pi, oops, I need pi. All right, so pi, all right, over 2. All right, so that's the x value. And then plus pi over 4. All right, so let's check the answer. Submit for testing. All right, it came back and it looks like we got this one correctly. All right, that's it. I hope that this was clear.